Now, life being the way it is, you know that mechanical and electronic stuff doesn't always work the way it should. And so sometimes you'll find that a component of an approach isn't working. Most of the time that doesn't mean you have to do a different approach. Usually it just means a small adjustment in the approach minimums. Let's take a look at what happens when you have inoperative components. And let's start with the RVR, the Runway Visual Range. This ILS approach to Mobile, Alabama shows a visibility requirement of 2,400 feet RVR. But what do you do if you hear on the ATIS that the RVR equipment is out of service? Well, it's simple. You convert RVR to its equivalent in statute miles of visibility. To do the conversion, go to page A1 in the front of your approach chart book and look in the middle table. The left column gives you RVR in feet, and the right column gives the equivalent visibility in statute miles. So you can see that an RVR of 2,400 feet is the same as 1/2 mile visibility. Keeping the same formula here, you see an RVR of 5,000 feet would translate to 1 mile. You'll notice the conversion between feet of RVR and statute miles isn't exact, but these are the numbers that the FAA wants you to use. You already know how much help the approach lights can give you for landing after an ILS approach. Well, when approach designers determine the visibility minimums for an approach, their calculations include how much help you'll get from those lights. So it stands to reason then that if the approach lights aren't working, your required visibility will be higher. The question is, how much higher? Well, to get that answer, go to the inside front cover of the approach chart book to the inoperative components and visual aids table. The left column lists the inoperative component. The middle column specifies the aircraft approach category, and the right column gives the visibility adjustment. Let's assume you're flying the Jacksonville, North Carolina ILS Runway 5 approach. It has the standard ILS visibility minimum of 1/2 mile. But approach control told you that the approach light system is out of service. In the Jacksonville Airport diagram, you see an A5. And the legend tells you that stands for MALSR, the Medium Intensity Approach Lighting System with Runway Alignment Indicator Lights. Since the MALSR approach system isn't working, you look at the inoperative components table to see how much to adjust your visibility. When you get to the table, you will see 4 sections, each dealing with different types of approaches. Now, Section 1 is for an ILS approach with standard visibility minimums, like the ILS to Jacksonville. If any of the approach light systems listed is not working, notice the list does include the MALSR, you need to increase the visibility on the approach by 1/4 of a mile. That would give you a new visibility requirement for the approach of 3/4 of a mile. But what if your visibility requirement is listed in RVR, like the 2,400 RVR on this ILS Runway 14 approach to Mobile? You know from looking at the RVR to miles conversion table that 2,400 RVR is 1/2 mile. Add the 1/4 mile increase for the approach light system not working, and again your new visibility requirement is 3/4 of a mile. To convert that back into RVR, which is how the visibility will be reported for that runway, find 3/4 of a mile in the table. The RVR equivalent is 4,000 feet. Take a look now at the ILS Runway 17 left approach to Colorado Springs. As we discussed earlier, because this runway has touchdown zone lights, runway centerline lights, and RVR, the visibility minimum for this approach is an RVR of 1,800 feet. That's only 5/16 of a mile. The FAA is happy with a visibility requirement that low on this approach, as long as the pilot knows what the visibility really is. If the RVR equipment is not working, the visibility requirement will go up. By the way, ILS approaches with a visibility minimum of 1,800 RVR are the only situation where not having RVR information will require you to increase the visibility requirement. Take a look in the inoperative components table at Section 2. That section is for an ILS with a visibility minimum of 1,800 RVR. If RVR isn't available, the visibility requirement goes up to 1/2 mile. Notice that it is to 1/2 mile, not by 1/2 mile. If RVR information is available, but the TDZL, touchdown zone lights, or RCLS, runway centerline lights, are not, the visibility requirement is now 2,400 RVR. And if the approach light system is not working, the visibility requirement is 4,000 RVR. By the way, the inoperative components table covers visibility adjustments for more than just ILS approaches. Section 3 covers most non-precision approaches, including VOR, localizer, and GPS approaches. And Section 4 covers NDB approaches. How does Jeppesen deal with inoperative components? Well, they make it very easy for the pilot by putting all possible minimums right on the approach chart, here in the minimums section. What if the ILS component that's not working is the glide slope? Well, normally you would just convert to flying a localizer-only approach. That's what would happen on the ILS runway 35 approach to Independence, Kansas. Instead of a decision height of 1,056 feet and a visibility of 1/2 mile, you would have a localizer minimum descent altitude of 1,220 feet. And in this case, the visibility would remain at 1/2 mile. But look at the ILS runway 30 left approach to San Jose, California. If the glide slope is not utilized, there's a note here instead saying to use the localizer DME runway 30 left procedure. In this case, if you're flying the approach without a glide slope, you would use a completely different approach plate. One reason for having two different charts is that it helps to cut down on the clutter on the charts if the approach is complicated. Of course, if the localizer itself is out of service, you're out of luck. You'll have to pick a completely different approach to fly, such as a VOR or GPS approach. So even if some of that mechanical and electronic wizardry on an ILS approach has taken a vacation, it will normally create just a small hiccup. After all, the visibility would have to be really bad before these small increases in minimums keep you from getting in. With a slight adjustment of your minimums, you should be able to keep on trucking and land your Skyhawk safely.